This is a channel for learning Rust. It's an opportunity for me to learn it, live stream it, and then try to pass on any knowledge that I get. Last few weeks, we've been working on an application in order to learn Solana development. I think we're getting pretty far in it in the actual learning process that we're ready to start working on the actual application that I want to do. I want to create a basic lottery system, and I think just a fun way to mess with protocol development with Solana. The last few weeks, we've been trying to actually write data to chain, and we got that close last week, and I wanted to make sure that we got that done this week. So I spent a little time during the week and I figured it out. So I want to go ahead and let's jump over and take a look at what was different, like what did I get wrong, and let's see it work now. So the first thing is let's open up the code here. So really the first one is, and this was a weird one, is we needed to actually pull out the system program from our accounts that we passed in. Like we needed to literally do this step. If I were, whoops. If I were to comment this out as if it never happened, it would literally throw an error that system program isn't available. That was a little strange, but cool. The next thing that was wrong is the create account here. I had this as the system program, which is probably why actually, I don't know. But I had this as a system program. And if you look here, you have the owner. It says the owner of the account. Well, if you set the system program as the owner of the account, then obviously you can't write to it because you're not the owner. So we changed this to the program ID to be the owner. So now we have that program derived account and the program is the owner of it. Another change I made, superficial, is just changing the seed because I was getting some weird conflicts since this deterministically figures out the program derived address, and I just was getting weird conflicts, so I just changed it to reduce that. Not a big deal. And that was really it for the creating, initializing, and writing our data. Did I do any changes here? As bytes, we'll get that. We added the whole thing. Yeah, nope, didn't make any changes here. I made a change on read, and I'll get to that in a second. So really, in that last one, like it was not a lot of different. We changed the owner, the program owner, and we yanked out or we pulled out the system account, and that was it. For here, change this vault to be just like the other one. Yeah, I don't think I changed anything other than my flipping back and forth here. Yeah, that was it. No changes on the client side. Uh, yeah. Okay, cool. So let's come back here to read data. So I talked last time where, we're just going to get the data, then we're going to splat it in there, write out, and we're good to go. In this case, I was just doing a raw string. I just wanted to get a raw string into the system. I'm also, for the most part, not doing many checks. So when we go to write or to go to pull the data back out, we're going to get the account data. I'm going to borrow it. Then in here I have, hey, let's get the first 22 bytes of data because that's the length of the string here. So it's 22 bytes of UTF-8 data, and that's all I wanted to pull out. Otherwise, it's going to error on us. Then I converted it, from UTF-8 into a string slice. Once it validated it was okay, then it output the message, and that was it. So if we look at here, Data read from PDA account. Hello world on Solana. Nope. Data read from PDA account. So it did work. And so I'm not doing anything. Like I'm not passing in that data. It's actually pulling it out. So good job. We're getting there. So brain just went left. Um yeah. So I think this shows that we're successfully writing to the chain and pulling the data back out. We're using our client to actually do some of that work. Cool. The only difference in our actual application, and we're going to do a little playing with it, is that we need to take the data that we're sending it, we need to serialize it and then save that. And then we're going to need to pull out all of that data off the chain and deserialize it from the chain and into a data structure, probably using Borscht again to push down and pull back. So that is really the only main difference. We'll probably have some different writing and reading patterns from here, since I'm just doing a basic string in this case. So really, we're ready to kind of like think through our application. But if we want to, out of curiosity, let's be a little crazy here. Let's change this to I am data. And then we're going to do that. Let's run it. It's got to build it first and then it'll run it. Okay, transaction successful. So then we're going to do read data. Cargo run. Transaction successful. And then, yeah, so still pulling in that original. If we do, so pretty sure I'm just going to add like 25 more characters to this. Build, yeah. Deploy. Should still be, so let's do a run. Oops. Cargo run. Successful. On Solana. Do. Okay. Oh, I am dumb. So this overwrote the data that was in there. That's actually something that I remember from Ethereum is in the stuff that you need to pull all the data off the chain for that thing, make the changes that you need, and then write it all back to chain. Forgot about that. Yeah. So in this case, we just overwrote some of the data in here. Makes sense. Yeah. That was actually a good reminder in that I was thinking that it was just going to append it. Anyway, doesn't matter. We now know a thing. All right. So with that in mind, let's do a little bit of planning. C dot, all right. So let's do make dir lottery. All right. So what is this? Lottery Solana program. The purpose of this program is to play with writing Solana programs, having never written one before. Goals. One, people can send Sol to an account and it will register them in the lottery. Two, weekly we will send a command to the program to generate a winner. We will send the winner 90% of the Sol imports that were sent in. I'm not going to do like a number generation, did yours match, kind of thing. We're just going to do this like you put money in and you kind of as a gamble that you're going to get it back out. So in this case, we need to be able to receive Sol, be able to get total Sol sent, Sol in account, need to record the address of the person that sent the Sol. Do we care? We don't care how much they sent. We just want to know by them sending Sol, they automatically are registered in it. And then, yeah. Really, we don't even care about that. We don't even care about this step. We're to be able to receive the Sol and then register who sent it. Yeah. So in this case, so weekly, we want, let's see. Pull list of users / addresses that sent Sol to our system. Randomly choose a user and address. Get the total amount of Sol in account. Send 90% of Sol to winner. Send 10% to admin. Clear accounts from being clear, just clear accounts to start fresh. Yeah. I mean, really, I think that covers it. I mean, someone's gonna send money to us. We're gonna be like, cool, you're now registered. and then they just wait. Week later, we're gonna execute a command, and it's going to be like, "Hey, who sent us money?" And we're gonna get that list, and then we're gonna be like, "Well, it is X, Y, and Z long, and we want to get a random number between that length." And then we're gonna grab that one. We're gonna save that in memory. Then we're going to say, hey, how much soul do we have? 100 soul? Awesome. Let's multiply that by 0.9, and we'll send that all to that person. Whatever is remaining, that's a key, we will send to the admin. The reason I say whatever's remaining is so we actually want to retrieve the amount again. And I say whatever's remaining because uh, might have transaction costs and or some rounding thing, so it's not a perfect 90%. So we don't want to do like 90% and then we send it. There was a rounding error, and when we did the original math, there's a few lamb ports off here and there, and now we're in a funky position. So if we just retrieve the total amount when we send to the admin, we're good to go. All right. I think that's it. I don't. There we go. Okay. So let's think here. Data structures. So we want. I mean, really, we want registrants. How about we should go users equal users? And really, we just want their address. Uh, do we actually really don't even care beyond that, do we? Because for the amount that they're going to send, it doesn't matter. We don't care. For sending, we're just going to do math based on the total amount. For yeah. And then we're just gonna do that. And then for the sender, we're gonna know who the payer is, and we're just gonna send. I'm gonna set a 10% to the admin slash payer account. Uh, I mean, we're not gonna worry about like history of this, of who gets it. Um, because we want this to be anonymous. Because why not? Yeah. So really, we actually only need. So we're gonna need a main. Let's see, Solana accounts. We're gonna need a master account that is our payer. Then we're gonna need a PDA account that is for holding users that have registered. This is something to research. Escrow account for users who send soul. Yeah. Okay. Yeah. think that's all we need from a Solana account perspective. Um, this is going to be a little research. I think so. We have data accounts that are program derived accounts. But I think we can create a normal account that the master account would have access to, or whoever would have access to. And that's the account that people would send land ports to. Yeah. Okay. So in that case, let's do data structures here. Storage. Let's do execution state. So we have a enum that is init. Receive. It's interesting. We'll have to figure this one out. Receive land ports. Totally need to research this. And then clear. No, we want the clear to be part of the confirmation process. So we just want the draw winner as well. Okay. I think that's good. Okay. All right. Program. Let's see. Program breakdown. See on-chain program. This will be a contract that executes on chain and manages the money and who. Client. This will initialize the program and do the and be the thing that triggers the drawing. Kind of being redundant because I'm trying to like think it through from different angles so that like once we're ready to start coding, we can kind of get it done as quick as possible. Really, so going back up here to storage, this is actually going to be a list of addresses. Or actually, we could probably do that. Let's keep it rusty of addresses because we're going to have a bunch. Okay. Here we have a, let's see. Let's see, how do we put this? How many bytes is an address in Solana that we would store in our program to then be able to send more Sol to later, I want to be able to do a calculation of how much space for an account. Hopefully it can derive what I'm after from that. Ooh, we get a double like response thing going. Okay. Let us see. Let's see. What? Okay. Solana address is a 32 bytes in size. When you store the Solana address in your program's account data, you need to allocate 32 bytes per address. Yeah. Calculate. Anyway, this is going to give a rough idea. Let's say 10 people max. Oh, hot. Look at that. I wonder if I subconsciously saw that and was like, "Hey, all that looks like a good thing." All the data you plan to keep in that account, right? I wonder. Need to maintain minimum balance in land ports to be rent right. That's why I'm trying to pre-calculate size. If you're using serialization like Borscht account for any overhead they introduce, Borscht is efficient and adds minimal overhead, usually just the length prefix for variable length data. Yeah, so yeah, that's what I was thinking is whatever the byte size for the owner is actually probably a better one. Plus the overhead of the extra that you need for storing for the Borscht conversion. So in that case, let's go to here. Let's see. So add here. We only want to allow up to 10 people to enter. That's just arbitrary. So with that in mind, for 10 people at 32 bytes per address, we have 320 bytes of space and 20 bytes. For overhead for a Borscht, let's go with 10 extra bytes. I don't want to look it up right now. So here's what we're gonna be conservative at 10 extra per, so that's 420 with Borscht. Now let's be extra conservative and just knock this up. Whoops. Okay. Let's just do 512. Sounds good to me. That way we're extra careful. If I was actually doing this in production, I would get a lot more detailed in this account and get a lot more specific because this could potentially open up maybe a vector for if causing problems. I'll just go with that. Say pre-allocate 512 bytes. Okay. Yeah. So what we're gonna do? Steps. 1, create contract. That can create accounts to create contract to receive, create contract and wire in receiving SOL and registering who sent it. Three. Wire in receiving SOL and output who sent it. Then we want to create a PDA for saving the accounts. Then serialize the write function to read data from account and deserialize it to a data structure. Uh, 5, write function to serialize the data structure and write it to the account. The reason I specifically did this is because we're going to have something else that's going to deserialize it, and now we have the reference to that account. We're going to add the data to that data structure, that vector of users. Then we're going to do a full write, and it's going to replace everything in the account. So actually, to serialize data structure, so we also probably need a 5 here. Write a function to clear the account, the data account, R6. Write a function to serialize the data structure and write it to the account. Yeah. So in this case, we'll deserialize, add it to it. Then the next step is we're going to clear it, write the data to it, write the new data to it. Then we should be good. 7, somewhere add validation. Actually, I don't. 7, write function to actually get the account and save it to the data structure. Get the sender pub key and save it to the data structure in the data account, trying to be specific. 8 is, so we want to write it. Okay, we want to write the function to the serialize. Blah! Write the function to serialize the data structure and write it to the account. Now that we have the CRUD operations available to us, we need to actually do the CRUD. So we're going to receive the user that sent us. We're going to receive the data, receive the SOL. We're going to get the account. Sorry. We're going to get the pub key. Then we're going to write the function that actually saves the data structure. So it's going to do the clear. Add validation to make sure that there are no more than 10 users. Cool. Okay. So that's all just dealing with receiving. So next we want to write function that, so now we want to do the drawing. We already know how to deserialize and get the data back out because we wrote that in the last one. Write a function that randomly pulls a, write a function that pulls a random user from the list. Write a function that sends, no, write a function that gets the total LAN ports from the whole escrow account. Write a function that, so we're pulling the money, we're getting the total from the escrow that sends 90% of the, so we're integrating it. Write a function that sends 90% of the LAN ports to the random user. Cool. Write a function that sends the remaining LAN ports to the payer account. 13. Call to clear the accounts. Call to clear the accounts. Account. I think that covers all of our steps. So we're going to receive it and to create a contract account. Okay. Record who it's going to be. We're going to get the random, pull the list, randomly get it, get our soul, send the 90%, send the rest to the admin player, clear the accounts. Yeah, we have a validation for 10 people. Can't think of anything else we want the system to do. Let's see, implementation steps. Okay. So in this, we probably modify the utility script to add regular accounts. Okay. This is going to be a learning step because I am unsure how to know who sends LAN ports. How to, like, I'm sure there's a way to hook, say, hey, if this account receives something, register it and do a thing. I just don't know how to do it. Create a PDA for, yeah, I mean, we know how to do this. We have code. Write a function to read data from the account and deserialize it. Okay. Uh, Figure out how to serialize data with Borscht. Like that just we know how to do it, but and to save. I mean, really, it's a Borscht deserialized with Serd. It's just a how do you do it? Like it's the tactical how do you do it? Write a function to clear the data. I mean, that's literally gonna be instantiate a new. Let's just write that. Instantiate a new account slash user data structure and save it to the account. Okay. I need to name things better. Totally doing a terrible job at naming. All right. Write a function to serialize the data structure. I mean, once we know how to do the serialize, so yeah, I think again gonna be not be really. We know how to do that with code example ish. Add validation. Let's see. Let's prevent from adding more accounts if we have 10 already in the system. Write a function that pulls a random. Figure out how to do random numbers with Rust. Trying to go through like what are details that I need to fill in, like things that I don't know. Um, how do I do that thing? Write a function that gets the total LAN ports. Yeah, this is totally. I just don't know how to do it. I am sure there's a function system or like a function call that's like you get the account and you just do like total amount or total available or something like that. Write a function that says 90%. I mean, so this is going to be, yeah, I think this is going to invoke a transfer. So it's going to be a system program thing. So this is just going to be some math and then system program invocation. And then this is going to be the same thing. So really, we want to abstract, write a function that takes an account slash address and a total to send, and it invokes. So that way we have just a function that we can call to for this and this. So then it's just maybe like a 1 or 2 line function call. Yep. And then call to clear the accounts where we did earlier. So it's just a function call. Okay. Just trying to think if there's anything else. So how are we going to know? How are we going to know it worked? Really, from a testing perspective, we would really just get a balance using the Solana. We just need the account pub key, which we'll get when we generate the account. And then we can just request the balance of that. And so after somebody sends it, we'll request the balance. We'll need to create some dummy accounts. Okay. 14. Create X. No, we want to do here. Create modify the utility script to add X amount of dummy accounts for testing sending money. This will need to do the standard airdrop. We will for test. So yeah, let's talk about testing. We'll want to test, write a bash script because I think we can just do it with the command line to send random amounts of SOL between 1 and 15, random number out of my head, to the escrow account. Yeah, so that way we can just do it over and over and over again, and really only need to save. Then we can only need to save that account to the bash file one time. So that just helps us test over and over. Trying to think of like how to test this consistently and quickly. So we're going to invoke the program on the client side. Really, the only thing we're going to do, create the invocations function to create the PDA account. 16, deploy the contract. Like, it's kind of an important thing to do. Let's see. So when we go to invoke it, we're going to have first one is to init it, and that'll create the program derived account that we're going to use. That's really the only thing that's going to do is create that account and have it ready to use. I mean, do we initialize it with an empty data structure? Or do we just leave it empty? You know, the positive of that is you can just, when the program goes to execute, just deserializes and just goes on about its business. You don't necessarily have to check if there is any data in that account. Outside of that, you could just check that there is no data in the account, and you just don't do anything, after that. Or do we save anything by doing the empty data structure later for later? So if we clear it, add the empty data structure, then we can just assume that it's always there. And we don't have to do a check every time. Hey, is there data? If there is data, do a thing. So let's do that. Create account. Initialize the storage data structure as empty. Yep, and then up here on the clear, write a call clear. Write a function to clear the data account. Write a function to clear the data account. Instantiate a new account user data structure and save it to the account. I already did it. Like, I already had that in the plan. I just didn't think about it in that way at that time. Okay, so we have that. So we've set it where we initialize the new program, the program derived account. We've saved the data in there. The init does not need to do anything else. We'll probably just throw some messages out. Hey, it's done. The next thing, user sends, we've got to hook in, save the data. Yeah, I mean, we have the accounts. We wrote the thing to have the accounts. We're gonna write a script to send that data. Let's see. Add a report function that pulls all of the wallet quantities. That way we can like send it and we get some feedback in there of like what's going on. Yeah. That way we can validate that we're sending it. So once we send it, it'll do the steps that we outline. Okay, so then we have to manually call the invoke to draw. We don't need to send any data with it, other than, hey, pull from this, derive the account from this. It's going to deserialize. It's going to pull the random. It's going to then really, in the initialize the empty data structure, can we call the clear method? So we're going to grab the random, we're going to do the math, we're going to do the send. We have a function in there to get those amounts. And then we're going to send it, and we're going to call the clear. We're going to do some logging output. I think that's it. I think this is the plan. I think this is our implementation steps. Yeah. I think this is a good plan. Let me read through here again. We have basic data structure. In the init, we're not going to pass anything in. In the drawing, we're not going to pass anything in. Yeah. This is the amount of data we need to allocate. Yeah, these are the two things that are going to need to happen. We're going to have to match on. Yeah, we have our master that is the main one for us to use. Then we have the PDA account. That's internal, the internal account. We have our escrow account. Okay. Yeah. I think that's it. I think we're good. I think we have a solid plan. And I think next week we're going to can't talk. So I think we have a solid plan, and I think next week we're going to be ready to hit the ground running and actually doing these things. I think we've come up with a plan that will allow us to reduce the friction of just trying to figure out what we want to do. So we can just go boom, 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 boom. I mean, this is kind of normal project management and creation to figure out like how you're actually going to do and execute a thing in an efficient manner. So Abraham Lincoln had a famous quote: if you give me 6 hours to cut down a tree, I'll spend the first 4 hours sharpening the axe. And actually really believe that. It's like if you could do as much upfront planning as possible, you can eliminate a bunch of guesswork that you need. You're not going to get it all. There's totally something in here I missed. especially around the ambiguous parts. And so, but I worked out several things. As an example, I worked out the, hey, when we go to initialize the account, can we just call the clear function instead of re-implementing that? By having that in my brain early on in the process, when it comes to it, like it doesn't have to be a thing that I just randomly think about or just totally miss. So I think we have a good plan. And let me think about my schedule. We should probably be able to start it next week. Um, Trying to think. I have vacations coming up. I have trips coming up. And so if I don't do a live stream, I'm gonna try to pre-record and do regular, like a post, just a regular video. So stay tuned for that and join me next time.